So hello everybody, and sorry for the short delay. I hope you had a good start to the conference so far. I will talk about gRPC. So let's look at what gRPC is. gRPC was developed or is developed by Google, and it evolved from Google's internal framework called Stubby. So the first stable release was last year in summer. Now gRPC is already at version 1.4. And recently it joined the Cloud Native Computing Foundation, which is also the home for well-known products such as Kubernetes. So in a nutshell, gRPC is a framework for remote procedure calls. And this basically means that you describe your services and the messages that they exchange using an IDL. In gRPC, we use proto 3 syntax. And with the help of these descriptions, we were able to generate source code in different languages, one of them being Scala. So there is also support for Java and C#, Python, and I think about 10 languages. So on the server side, you then implement the interfaces that have been generated. And on the client side, you use so-called stubs to call the services. Let's look at the benefits. Most projects nowadays use HTTP with JSON. And while JSON is quite nice to work with, it's not a very efficient format, so it's quite verbose to read. What's good for humans but bad for machines. So using gRPC, we have a lot smaller messages, and this results in fast transportation, as well as fast deserialization. And what's also quite important is that compared to JSON, this message format requires a lot less CPU power to deserialize. And that's important for mobile devices, and as well as in the cloud, where you often have to pay per CPU power. So additionally, gRPC is using HTTP2 based transport. This means that you get a lot of the benefits that come with using this new protocol. I've mentioned a few here, and I recommend that if you're interested in the more low-level benefits of using gRPC, that you watch some talks by Mete Atamel. I think I pronounced it not correctly, but sorry. Who is working at Google. And yeah, he's doing a lot of talks on the subject, and you can find one presentation that I especially like under this link. So I will put the slides online after the talk, and you can watch it if you're interested. So more benefits for us as users is that it's quite nice to have a service description using an IDL, because it enables us to generate a boilerplate code for our services and clients. And one common error when using JSON is that some field names are simply misspelled, or different type with underscore or no underscore. And using gRPC, you basically can't make that errors. So it's also easier to work with new or unknown APIs, because with JSON, you basically have to open your browser and look at the documentation, see what the JSON looks like that you have to send. And in gRPC, you can just use the auto-completion of your IDE, like IntelliJ, because it's all source code, so you get all the auto-completion goodness that you're used to. Furthermore, compared to JSON, gRPC already comes with a good support for versioning and evolving services. So basically, as long as you don't make changes to existing fields, and just add new fields, for example, then these versions are compatible to each other, and it's quite a nice thing to have. So, who is using gRPC? These are, I think, some of the most well-known companies that are using it at the moment. What I find especially interesting is that a few weeks ago, Lightband announced that Lagom will also use gRPC in the future, and I think that's a really nice thing, so I'm very excited to see how they're going to implement it. And yes, as awesome as gRPC is, just remember that it's only a tool like JSON, so you still need to be aware that you're actually calling services. It's quite important to have a good architecture, and yeah, it doesn't save you from any consequences that using or building a distributed system involves. So let's have enough of the theory and get started with some coding. gRPC support in Scala is provided via ScalaPB, which is short for Scala Protocol Buffers. So it contains a compiler plugin that you can just put in your SVT build, and then it will compile your protocol definitions for you. Then we also have these runtime dependencies that you need if you want to use gRPC. Additionally, ScalaPB also comes with support for Scala.js and Spark, but we won't cover these topics in this talk. And ScalaPB is basically really just there to generate Scala code from your protocol definitions. And for the runtime, you will actually need to use gRPC Java because there is no implementation of gRPC in Scala yet. So how do we compile protocol buffers in our project? So basically what we have to do is add this compiler plugin in your plugins SVT. And additionally, there are some dependencies that you need to put in your build SVT. If you just need to compile protocol buffers, then these 1 line or 3 lines, depending on how you format it, would be enough. But if you want to use gRPC, then you will have to add these 3 dependencies as well. So as soon as you put that code in your project, it will enable code generation when you run SVT compile. And it will look for proto files under source main protobuf and put the generated Scala source in your target folder. And additionally, it will also try to compile these generated sources. If you want to skip that step and just have the sources generated, then you can run proto generate. And let's try this out. So let's start with a well-known Hello World example. So we want to write a service that accepts a person, which would be the name in this case, and returns a simple greeting. So this is a very simple proto file, or one of the simple services that you can define. Basically, we specify that we're going to use Proto 3. There are also older versions of protocol buffers, but if you want to use gRPC, you're going to use the latest. Additionally, we can specify a package for our protocol definitions, and then we already can use the gRPC-specific service keyword, name our service, and each method that this service is going to provide will start with the keyword RPC, followed by the method name. In this case, it's just a single argument. We will later look at how to define streaming services. And we then define the return type. And we define the messages just down here. So if we then run spt compile, which we can try out right here. So this is the service definition that you just saw on the slides, right? And if I now go to my terminal, switch to this one, I get up here. Yes. Oh, what's that? Let's try to get it away. Okay, now it's gone. Great. So when I now start my SPT, and let's clean everything so you can see redoing it. And if we now run compile, you should see no errors, and after a few seconds, yeah. If we now go back to IntelliJ and look in our target folder, you will see that here under source managed, we will have some new files that have been generated for us. So looking at these files, we can see the package name that we specified in our proto file, as well as the file name, which will be appended as an additional package. And then we will have a file for each message that we defined, as well as a file containing the service traits and stubs that we are going to implement or call, and an additional file that you probably won't need as a user that contains some meta information about the generated service. So what do these files actually contain? For message classes, it's mostly a case class plus a companion object, fields based on the definitions in your proto file, as well as some useful helper methods, like, for example, for a person, you could have person with name or with age, so which corresponds to the typical builder pattern, as well as some lenses, which can be useful if you want to update deeply nested case classes, as well as some internal functionality that enables the framework to actually read and write the message from a coded input stream or output stream. So, and the service object will contain the trait that will be implemented by concrete services. This is the server side, and on the client side, so the user who wants to call the service will be provided with two different kinds of stubs. So the preferred one is the async stub, which will return a future in our simple example. And additionally, there's also something called the blocking stub, which is a synchronous call, but as always in distributed environments, you should use this one carefully, because it will really block your application until the call has returned. Additionally, we have here a bind service method, which will be used that as soon as you have implemented the service trait, you need to bind the service to a concrete implementation, as you will see in the example later. So ScalaPB provides us with some customization options. Remember that dependency in our build SPT, this one is actually needed to get these customizations in our project. And if we add that import, we can use these ScalaPB options in our file, which allows us to, for example, specify a different Scala package name than the default package, or say that we don't want to have 4 separate files generated, but to put everything in one file. Yeah, or add some custom imports on top, which can be quite useful if you're going to use custom traits, which we'll see in the example shortly. So let's start with looking at something that I think is one of the most important features that ScalaPB provides. It's called primitive wrappers. To understand why we need that feature is we need to look at how gRPC would treat parameters per default. So if we look at this proto file, which looks quite similar to the Hello World example that we previously had, you will see that for simple types, like this message here, gRPC will assume a default value of an empty string, which might be okay in some cases, but usually in Scala, what we would like to have is an option, right? So while we get this functionality for more complex message types, primitive types will basically result in some default value. Now, yeah, that's what I just said in the summary. So as you can see, especially with Boolean valence, this is quite bad, because if you receive such a message, there is no way to tell if the user really set the value to false, or if it has been just missing. These two values will be identically. So it's really better to have an option. And how do we get this? The simple solution is that we can call something called primitive wrappers. Actually, that's a small proto file provided by Google, which you can import. And then, instead of just using the type string, we say that our field message has the type string value. And if you now generate your Scala source code from this file, then we will get an option of string, which is really what you always should do when working with primitives. Great. Okay, let's have a look at another useful feature. So let's imagine that you have a lot of messages and you want all your messages to share a common supertype. Then this is, let's say your create rocking message should be a supertype of this message to be greeted. ScalaPB makes it possible to do that by providing this option, where you can say, okay, my message to be greeted should extend my custom type. And if you put that line here, you will see that in a generate source code, additionally to some standard gRPC functionality, you will also, the class will also extend your custom trait. So that's another thing that you might want to use in your project. And the last customization option that we're going to look at is something called custom types. So let's imagine that our person should have an additional field storing its birthday. And a birthday consists of a month and a day. There is no birthday type in standard protocol buffers. So what we can do is we can say, okay, in our binary format, this will be a string, but please, in our Scala types, let's have a type of birthday for this field. And one question that this might create is, how does gRPC know how to create a birthday from a string? So the answer is that if you want to use custom types, you also have to provide a type mapper in your companion object of the type that you want to use, which provides a function or two functions for both directions to create a birthday from a string and to create a string from a birthday. And these methods need to be defined implicit. And if you do that, then gRPC will be able to use your type mappers for deserialization. And in case that you're not able to put some code in the companion object because you want to use a type that you haven't created, like say Java date or something, you can also create your type mapper in another location and then import it via the import option that we've seen earlier. And maybe one thing to say is that I think custom types can be quite useful in some cases, but if you use a custom type and let's say the user has put some invalid data there, then you won't be able to deserialize the value or just deserialize it to a default value. So in that case, you basically lose the possibility to somehow further work with the invalid data and, I don't know, put it into a log or something, or try to recover from the error. So I think basically in most cases it's better to deserialize the value in a simple field like a string and then try to add or transform the field and validate it in a later step. So if that step fails, you at least have the primitive value that you can use. Like I said, there are even more customization options, but yeah, I think there's more interesting things to look at. And so if you really want to use gRPC, then you can just have a look at these pages. And I think the documentation of ScalaPB is really good for an open source project. And yeah, I think you will have no problems in looking up what you need. So, okay, let's go to the different communication styles that gRPC is supporting. Basically, we have these 4 options. We've always seen the most simple one, which is that the client sends a single request to the server and receives a single response in return. Then there is also server-side streaming, where the client sends a single request to the server and receives a stream of responses in return. Additionally, as the example where the client will send a lot of data in a stream to the server and receives a single response in the end. And additionally, there is the case where both sides send a stream of data. So let's look at the first one in more detail again, where I think I've skipped some iPhone examples, so let's just forward here to where we are. So, yeah, that's enough. Good. So if you remember our simple hello world example, this service definition will generate that trait that you can see down there. And in this example, the client is just sending a single request to the server, and the server returns a future of the response. So how would we actually implement that service? Let's, oh no, that's not good. Maybe we can, oh right, it's I think because we're not. Okay, then let's go to the, let's see if it's, oh no, it has this conflict. Okay, that looks better. Yes, sorry, I think it's a little bit big, but okay, you can read it. Okay, let's have a look at the service first. Yeah, that's basically the same code that you can see on the slide with a little pattern matching here. So in case our person, the client has not provided a person to us, then we're just going to greet an anonymous person. And as usual, we can just return a future. And on the client side, which is more interesting in this case, I think, is so we start by building a channel, which is a virtual connection to a specific service, where we have to specify the host and port where the service is running, as well as in our example, we're not going to use any kind of encryption because it's easier for demo purposes. And that's what this use plaintext call here does. It's a little bit confusing. I think at Scala Day somebody assumed that what this method does is not use a serial format but use plaintext. But no, it just says that we're not going to use encryption. So, and then we can create our stub using this generated class and the generated stub method. And after we've done that, there is nothing that's specific to gRPC anymore for the client. So as soon as you've got your stub, you can just call it as you would call any normal method on your machine. So yes, that's what you see here. So as soon as we have generated our stub, we can just call this method here as normal. And that's what I meant when I said that it's quite nice to have autocompletion, because let's imagine that the stub contains 20 methods with a lot of parameters. Then you could just use the standard IntelliJ autocompletion for that, which is quite nice. Okay. I think we're a little bit short on time, so let's not run this and go to the streaming examples. Right. So there is the case of server-side streaming that I mentioned. So imagine the following service. We have a clock service where the client indicates that it wants to receive the current time again and again. So the client just sends a single request to the service, and the service will return a stream of time responses. In our implementation, let's say that the service will return the current time every few seconds, infinitely, as long as the client stays connected. So if we have this proto definition, the generated code, the difference that you will now see is that our service is now not returning a value, but instead is returning unit. But it takes an additional argument, which is a stream observer provided by the client. And what this enables is that now our service, instead of returning the result, will just use this observer and call the onNext method as soon as it has a new value enabled provided. So that's what you can see here. And on the client side, so it's quite easy to build such an observer. Everything that you have to do is implement these three methods. That basically tells us what to do on error when the stream has finished, and what to do on each received value. And as soon as you've built that observer, you can again just call the method as you would on a local one, and provide your request and the observer to the client that the service will call. So for bi-directional streaming, it looks almost the same, but this time the service also provides an observer that will be passed to the client. So additionally to receiving a stream of data, the client can now also publish a stream of data to the service, which works exactly the same as on the server side. So what you can see here is the sum service on top, which now also builds a stream observer, which it passes back to the client. And on the client side, we can then use that observer to send values to the service. So maybe let's run this example because it's quite nice to actually see something. Right. So let's start the server in that window up here, and the client down here. So basically what that service does is the client is sending random numbers to the service, and the service will sum them up and return the current result to the client. So we can see it's now saying adding number 6, and it gets the current sum 6. Now it's adding 7, getting back 13, and this is basically going on forever, every few seconds. And yeah. So I think that's really nice, easy way to get a streaming service implementation. So that's definitely something very cool about gRPC. So let's stop that again and go back to our slides. So quickly, some best practices that kind of are personal opinion of me. So it's basically how to share your proto definitions. If you're working in a project where most people are using Scala, then I think the best way is to just put your definitions in a separate project. You can then compile these definitions and publish the generated class files in some repository like Artifactory. And if you then want to write a client or service that uses that definitions, you just have to add that dependency like you usually would. There is no need to add ScalaPB or something else gRPC specific to that service or client. That will all be pulled in by that other dependency. So yeah, that works very well. Additionally, if you publish your proto definitions to something like Artifactory, then you're going to have versioning out of the box. So just whenever you change your definitions, you increase the version and republish, and that way there is no possibility that, unless you overwrite that explicitly in your repository, but I think that's not something that you can do by accident, so it usually shouldn't happen that you update your proto definitions and suddenly your services don't compile anymore. So also, I recommend that you don't use the generated entities directly in your code. That's basically because, as you've seen in proto files, everything is optional, and that's most likely not what you want in your business domain. So for that reason, and that you most likely will need some more complex validation, I recommend that you use these generated files for transport, but write your own case classes when you work with it in your business code. So basically, that's I think that's all you need to start with gRPC, with writing gRPC applications in Scala, because, as I said in the beginning, there is no gRPC implementation in Scala yet. So for everything that's basically needed for runtime, like adding headers or authentication, you will need to look at gRPC Java. And yeah, it has a great documentation and a Google group, so yeah, it's quite nice to use actually. I mean, maybe there will be a Scala wrapper sometime in the future, but I think for now it's still quite nice to work with gRPC. Some useful links. I will add some more before I put those slides online, so you can read it up when you have time. And last but not least, some credits to the people working on ScalaPB and gRPC. Both projects are open source and freely available. So I think that's really great. So thanks a lot to those people. And thanks. So that was my presentation. If you have any questions, then I think we have a couple of minutes left, or additional feedback.
Yes, we have a couple of minutes left. So
yeah, send it just to my Twitter handle.
Who wants to ask a question? Go, go, go.
Hi, I want to ask about the streaming capabilities. What about disconnections and that kind of stuff? Do I need to handle it myself?
Yeah. There you will, if you have seen this on error method that you define in your observer. So if the connection drops, then you will actually be able to detect it in your on error method. I can quickly show that even in my example. So let's start the service in client again. Run this. Oops. So you will see that if I run my server on my client, which one do you want to disconnect? Is this the service? Or okay, let's just say we kill this one. Then you see that the client will, yeah, it's actually down there at the bottom. Can you see it or not? Yeah. It will.
The question was, will it reconnect automatically when the server is up?
No, I think that won't happen.
Well, the slides did say that this is not a unicorn and that you need to still do some of the
We can try it out. We can try it out, but I think that the channel will probably be closed now or something like that. Oh yes, right, and the specification of the reactive streams, I think basically says that once on error has been called, it's not valid to call on next again. So yeah, so that basically shouldn't be possible now. So you would have to reconnect.
Okay, so thank you, Petra, for a really, really detailed introduction to gRPC and ScalaPB. So please